sir. Sure.
sir.
Sure, namaste. So, first of all, thank you all for inviting me as the keynote speaker at SRM University. Thanks to the organizer and thanks to the SRM family, and finally, thanks to all the audience. So, in today's lecture, I will mostly talk about my recent education initiative that I have started with machine learning, because I think many of the participants here are students and they really wants to learn all the related things in machine learning. So let me start. Let me share my screen quickly, and so all right. So can you all see my screen?
Yes, sir.
Yes, okay, sir. Perfect. So, all right. So, well, I am Arghya Kusum Das, and normally I goes by Argo. And I did my PhD in computer science from Louisiana State University. And currently, I am an assistant professor of computer science in University of Alaska Fairbanks. And Alaska Fairbanks means it's just near the North Pole. It's only 200 miles from the pole. And now, here. This university is the flagship university of Alaska, and we are very much well known for the polar research and Arctic Circle related research, and lots of different space research and supercomputing things. And and also I am an advisory board member of Institute Data Education Initiative, and previously I did an organized an event on a Python workshop in SRM University, and I really enjoyed that. So I really enjoyed interacting with the students in SRM. So great. So all right. So let me go directly to my presentation. So, all right, so here in this course, I am going to talk about Institute's recent AI education initiative that we started very recently. So, this is basically the course. Well, we should not say that just one course. This is basically a curriculum, a group of courses, which is known as machine learning for software developers. And for this course, basically, we have partnered with Facebook, Fractal, Fidelity, IBM, and of course, Institute is there. So all the developers from these industrial, all these companies have worked together to develop the curriculum, different parts of the curriculum, and then we have merged it, and then we are giving a cutting edge essence of the machine learning right now. So, and this course have been adopted in UW Platteville, University of Wisconsin Platteville, and even when I left my previous university at University of Wisconsin Platteville, they are still utilizing that course and everything. And in this talk, I'm going to talk about, I'm going to give you a little bit of background of like what is the current state of machine learning and how this course can help you all. And so here is the agenda. So first I will discuss about the current state of machine learning, then the expected learning outcomes. So what can be the expected learning outcomes in current situation from a machine learning course, and which is basically a developer's perspective, not just a mathematician's perspective. So that's very important. And then I will briefly discuss about Institute and its collaborative effort. Then I will talk about the course highlights. And finally, I will show you a little bit of a coding demo and how we are trying to develop a developer's mindset among all our students. So all these things I am going to discuss in the next half an hour. And finally, I will talk about what is our goal and where we are moving with all these educational components and what are our goals. So Here is the current state of current state of machine learning is basically it is a cross disciplinary, so it's not only in science, technology or mathematics or anything, but it became non-STEM also. So people from I mean the students from liberal arts also trying to learn machine learning to do like fraud detection in art and several other reasons. Last semester I have actually collaborated with a professor from history department who was trying to develop some kind of tool so that they can get they can extract some knowledge about the veterans who fought in the Vietnam War. So those are pretty interesting projects. So this is just to tell you that, well, not only computer science or not only the business folks or the scientists are utilizing machine learning, but that actually expanded to a broader range, including history, including liberal arts, including many other different fields. So basically, it is everywhere, starting from e-commerce to social media to automated vehicle to targeted advertisement, personalized medicine, smart IoT devices, virtual assistant. Just you have to name something, and AI and ML is there. So this is basically going to be a never-ending list in near future. The way it is expanding, everyone needs to know a little bit of AI or ML, artificial intelligence or machine learning. So everyone needs to do it. So it is slowly, it is basically becoming like learning science and maths in high school. So it is becoming like that. So anyway, so here the point is all the existing curriculum are mostly like focused on either mathematics or they have missed several other components. So basically the part is they are not very much capable to develop the developer's mindset. I mean, what you need to know to become productive in an industrial setup or in a competitive setup or in a research setup, what do you need to do with machine learning? You will get a lots of codes all across the internet. Those are like full of noise. So sometimes it will work for your research project, sometimes it will not work for your research project. And after hovering around this code and that code, you will realize that, especially happens to non-STEM major students, you will realize that you are completely lost at some point of time. You did not learn anything, and also it is not becoming very productive. After several months of effort, you will see that, well, you are really not becoming productive. Maybe you know lots of different theories, those are going in the back of your mind, but you are not being able to become productive. So basically ML curriculum needs to be redesigned and need to be better. So it should be updated to fit the business need, what the business is demanding. It should be tuned for the software developer's perspective, not only for the theory perspective and all these things. So there should be much more focus on developing the codes, developing the software and all these things. So here it's not only about coding. So whenever it comes to the software developer, it's not only about the coding. You have to consider like the ML project management. These type of project management things are little bit different from the traditional software development project cycle, because the client's demand is changing every day, because every hour the client is actually getting to know that, well, I can perform this thing with machine learning, so can my vendor help me doing that? So their needs are changing very, very, very frequently to exploit machine learning for many different purposes. So the entire vendor team needs to be significantly more agile in nature. They should be very much a recipient in terms of changes. And that's when but on the other hand, which is a little bit counterintuitive, which is like, well, your machine learning model should be a little bit visionary also, I mean, so that it can support many different things in future. So what should be the better sweet point, how to manage this entire project so that the client will be happy? Also, it will be a robust model, but it will change. I mean, it can stay in the market for a long time, but it will stay. It will be adaptive to change. So those things need to be considered. So and also it should be accessible by people from different background, including the non-STEM people, because just you may end up in a job which is not just directly related to the computer science. You may be ended up in a job which is simply uh, so yeah, so which is basically not a computer science, but maybe an electrical engineering or something like that, and or maybe totally in the art domain or digital art domain, which is currently a big thing after this non-fungible token and blockchain related things. Digital art became like pretty popular, pretty technical in these days. So you may end up in that type of job, and there also you need to work with non-STEM people. So those things should be included in machine learning curriculum. When the machine learning curriculum will be designed, all these issues needs to be considered. So basically, the expected learning outcomes should incorporate the developer's perspective, not just a scientist or just a researcher or just a mathematician's perspective. So basically, there should be more focus on coding and development activities. So you need to generate the fact like, all right, ML is not only mathematics here. So it is all about like understanding of data. It's about type of the problem. It's about the customer's need. It's like a software development process. The way you treat a software, you have to start treating machine learning like that. And important skill set are becoming like efficient coding. It's not only developing the model, development developing the mathematical model, and what type of development techniques are you using, what type of project management strategies are you using to make your model robust, and all these things. So basically you have to consider several key performance indicators, which are like, let's say, the machine learning model. Whenever you will start developing a model, you should consider like all these key KPIs or key performance indicators. For example, like capable to analyze large data set, capable to extract more knowledge from less data, improve the accuracy as much as possible, improve the robustness so that it can handle lots of different types of data from the customer, less execution time, improve the performance to price, improve the return on investment. So lots of different KPIs you have to figure out. So far machine learning was all about like, well, improve the accuracy, and lately it was like, it should be high performance. There was no consideration of performance to price, no consideration of like improved return on investment. So those things are actually should be included in the curriculum itself, so that students can become more productive when they will hit the industry. So so these things should be kept in mind when designing the curriculum. And also the students need to understand the project workflow. So focus on the improve productivity, like how to use the libraries rather than developing from scratch. What is a better way to use TensorFlow, or what is a better way to use scikit-learn, or what is a better way to use PyTorch? All the different things you should know. I mean, rather than just knowing the mathematical model or mathematical understanding, these things should also be considered. For example, let's say your model, you have developed a very nice sophisticated model, but it is taking, let's say, 5 seconds, or let's say 5 days to train when you have developed with scikit-learn. since you do not really have the idea of what is TensorFlow, you could not develop the same model in TensorFlow, and you actually basically penalized. You are penalized because of its slow performance. So lots of different things you need to know as a ML expert. It's not only about the accuracy, it's about the performance of the tools, it's about the work, it's all about the entire workflow. Now, as an ML developer in the current era, you have to try different models with minimal code change with many different tools like scikit-learn, TensorFlow, PyTorch. Also, at the same time, you have to maintain all these CI/CD, like continuous integration and continuous deployment the type of strategies. So all these different things you have to take care of, and these things should be included in the project, included in the curriculum development process. And the big thing is ML projects are not just about theory anymore. There are a lot more there. So in a proper curriculum, there should be proper balance between theory and the development knowledge also is very necessary. So from that perspective, with that motivation, Institute has collaborated with multiple companies like Facebook, Fractal, Fidelity, IBM to develop a machine learning, a state-of-the-art machine learning course for software developer. Well, again, not a course, just let's call it curriculum. So here are a little bit of information about Institute and its collaborative effort. So here actually data education is one big data problem that we would like to solve here. So that's with that motivation, we collaborated with all our partners and developed this course. So here are a little bit of course highlight. So the expected audience, most of the time we always assume that the beginners, because as I have told, machine learning is not only for computer science or mathematicians anymore, not even for only the science majors, it's for the non-STEM major students also, from liberal arts, from history, from many different backgrounds. So in a proper machine learning course, you have to learn, you have to design in such a way so that the student can learn all the prerequisites. Now, learning the prerequisites is not a very easy task. Always you have to remember, fundamentally machine learning is developed on top of mathematics, and now you have to convey the message to the history student or someone, and all these things. So that's not a very easy task to do. So those things should be considered, and we have considered all these things, and based on that we have prepared our course. And many different, so these courses, this curriculum is actually targeted to all the university students who are aspiring to join machine learning industry. And since its scope is not STEM and non-STEM both, our expected audience is from all the different backgrounds. Or you can be a switching career to ML from an entirely thing, or project managers, team leads who are very new to machine learning project management. All these things we take care of in our curriculum. So these are our targeted audience. And here the main highlight is you will learn with Institute, you will learn the code developed by the industry practitioner. So as I told, we partnered with Facebook and all the people, Facebook, Fractal, Fidelity, and IBM Open Power, of course. And so from their code, you will learn. So you are going to learn from the best. So you will understand the basic workflow and the steps that are common in most of the machine learning project. We have handpicked, we figured it out, like what are the basic workflow. That was a big research for us, basically. How to extract the fundamental workflow in a machine learning project. Then we are presenting it to all our students. Then also you will get lots of chance to get your hands dirty with coding on Jupyter style notebook, opportunity to be involved in projects tuned for your needs. All these different things are there, but the main thing is we figured out what is the basic workflow and what are the steps that are common in machine learning project. And once you will nailed it, your machine learning understanding will be really, really, really very easy. You can be productive. That's all matter. And also when it comes to like getting your hands dirty with coding, we provide all the, I mean, virtual machines and containers that are optimized for different hardware environment, including open power, I mean, power environment, and all these things. And sometimes based on the project requirement, we offer the service also, I mean, server also. We have a strong collaboration with IBM, I mean, University of Oregon, where there is a very big IBM lab, with which from where we can get a lot of hardware resources for the student project perspective, project purpose or research purpose or anything. And so here is a small coding demo thing. I am coming to that in a few minutes. So basically, all right. So let me show you the coding demo, and then let me tell you what we are doing. So here is basically a code that you can see written in Jupyter style notebook. So what you can expect, as we have told, like we have figured out the fundamental workflow of any machine learning project, and then we are educating our student. So we have found that several steps are pretty common in all the machine learning project. For example, like how to generate the data set or how to download the data set. Let's just fix a standard for that. Then let's say scaling the data, visualize the full data set, then split the data set into training and test set, visualize the splits, and create the 2D arrays and all these different things. Everything, all these different things are pretty common in all the different models that we have found from everywhere. It may be a very complicated model, it may be a very small model, whatever it is, these things are common. And so this is basically conforming the workflow of the machine learning project, whatever it is. And then we have developed small demo codes, as you can see here, with all the different all the different tools basically. So basically what will happen, you will learn what are the fundamental concepts in the same code, which remains kind of similar in all the different codes. And the only thing that you will learn with let's say with a machine learning model, you will learn all the different tools. And you will learn all the different models also. So basically, if you see this code, you will see that, well, the entire pipeline is like this. And here, basically, we are using an SGD regressor, which is basically doing the job for linear regression over here. Now, when we are coming to this TensorFlow demo, the same linear regression code, and since we have found the workflow, the fundamental workflow, you will see that, well, the entire code, this generating data set, downloading data set, scaling the data, visualize the data, split data set, visualizing the splits, everything remains same. The only part which is different is just by the code change. So what will happen now, and also not only scikit-learn and TensorFlow, we have developed the similar type of coding with all the different tools. So for example, here also it is a model with PyTorch, as you can see. Here also everything is same, but just the model part is different. So in this way, basically, as a student, you can learn what are the fundamental things and how to try out many different tools very quickly. And you can easily develop your own model, just focus on the actual part, what you want to do, and that's it. So this way you can learn better. So these codes are basically showing you only the linear regression, but we have a umbrella of everything, like starting from linear regression to logistic regression, SVM, neural network, deep neural network, ResNet, all the different codes we have developed with all the different types of tools. So what will happen, let me see. So what will happen with that, your learning need will be definitely will be, you can definitely meet your learning need. So that was the small quotes that I wanted to show. So our goal is basically we want to develop like an ONNX like model zoo, uh, which is for, but specifically for machine learning education. So ONNX is a model zoo which is pretty popular, where from which you can get all the implementation of different types of deep neural network model developed in many different tools. So our goal is also like that at Institute, collaborate with many of our partners and come up with a model zoo. But here our motivation is to educate all the students, so that you can understand the fundamental workflow and become productive in industry. So this comes to a conclusion of today's presentation. Possibly so it is, yeah, almost it is 7:30, so 30 minutes here. And well, so this is our educational collab. I mean, we are always open. So in the end, as I tell always, and we actually collaborated with SRM. So, but once again, we are open for collaboration, course adoption for the university, improving the course, organizing workshop, hackathons, guest lectures, whatever way you want to collaborate, we are really open for it, and we are open for talking. So just send me an email and we will be happy to teach you. We will be happy to talk to you, and we will be happy to offer a state-of-the-art machine learning course in here together with Open Power Foundation. So yeah, so that actually concludes my talk. And in the end, I just would like to share, play a promo video for Institute by where we teach all these things. So that will take another 3 minutes maybe. So let me play the video. Technology is evolving every day. The jobs are changing at same pace. Learning the right tech skills to be productive is becoming harder and harder. Hilani got her bachelor's degree in electrical engineering, but landed up in a job at Data Power, a data analysis and IT company in the field of energy and power, where Hilani needs to develop several new skills. The life was stressful, learning new technologies all by herself and being productive at the same time was really, really hard. It started hampering Hilani's work-life balance. And Hilani is not the only one in this story. The entire Indian information technology workforce consists of almost 4.36 million people, among which only 215K students have CS or IT background every year. So that means almost 4.1 million skill gap is still there, which is counting up to 20x gap in required skill and the experts produced in the Indian IT market. So what will Hilani do now? How can she learn the new skills needed for data analysis and relevant technologies? How can she be productive very quickly? Thanks to Institute, Hilani registered to the Institute Learning Platform and developed the skill sets significantly quicker than she thought. I am Arghya Kusum Das, the developer of the Institute Learning Platform, and at Institute, our motivation is to make data, computer, and IT education available, accessible, and affordable to anyone, anywhere, anytime. With our proven pedagogical technique, live lectures, and hands-on experiences on cutting-edge hardware infrastructure, we offer the students the best education and prepare them very quickly, in weeks rather than waiting for months or years. We have strong collaboration with many different academic organizations and industry, which prepare our students with the right skill that the job demands in the current world. After 2 months of launching Institute, we got more than 150 registration already, and after a few sessions in the Indian market and teaching a few students, we got several great review which proved the credibility of Institute platform. Well, here I would like to pause once, and these are all the, I would like to mention that these are all the comments from the students from SRM Institute of Technology. So thanks for all your good comments, by the way. So that's about Institute. Here, data education is one big data problem that we solve. So yeah, that's it from my side, and just wanted to let you know that, well, 150 was just right after 2 months, and now Institute is a little bit older, and now we have more than 1,000 registrations. So if you want to learn more about machine learning and all these things, and if you want to be part of my research and all these things, please feel free to contact me, and I will be happy to help you all. Thank you.
Thank you, Agya. It was indeed a wonderful session. And I think we'll have a lot of students registering in on Institute. Um, I request all the participants to switch on your video so that we'll have a picture, a screenshot for us to remember. Students and participants, can you please switch on the video? Hello, Devesh sir.
Hello, hi. Am I audible?
Yes, sir.
Yeah, okay, good. Hi.
So, Agastya sir, Devi ma'am.
Yes, ma'am. Yes, ma'am.
Hello, Surya. And others also, please. Jayachandran sir, are you able to take a screenshot?
Yes, ma'am. So,
Ma'am,
Agastya
it is
sir?
done, ma'am. Screenshot is done.
Okay.
ma'am, Agastya sir, ma'am, Agastya sir.
I'll take care of that, ma'am.
Okay, okay, ma'am. And I thank Agya for his lecture. Next, it's time for our second guest of, thank you, sir. It's time for our next guest, Mr. Deve Sharma. And I'd like to give a small introduction about Devesh. He's a subject matter expert and technology advisor in collaboration with Dr. D.K. Panda and Object Automation to demonstrate capabilities on xScale HPC and xScale AI to end users. In his 16 plus years of career as a software developer, he spearheaded development of RDMA provider driver libraries for Broadcom, Emulex, and CDAC. His work scope includes contributions to various use cases of RDMA via MPI, storage, middleware, provider libraries, OpenUCX. He has been an expert of MVA Pitch and MVA Pitch GDR and its surrounding applications. Recently, he played a key role in using Broadcom's 200G and 1000G adapters on HPC workloads and demonstrated it at MVA Pitch Users Group MUG 2020 held at Ohio State University, Columbus. I request Dr. Deve Sharma, Chief Technologist of Oracle, to uh, to give his keynote address. Over to you, sir.
Thank you, Shamla, for giving such a nice introduction. Thank you all for inviting me for a talk. So, and thanks for a very nice talk from the Mr. Das. Um, Let me share my screen and then we'll start my discussion. Give me a moment.
Sure, sir.
Can you see my screen? Am I audible?
Yes, it's visible. Yes, yes, sir.
All right. So let me take you through to the role of high performance computing in the area of in the area of artificial intelligence. Um, so this is the agenda. So I will try to take you all in the deep dive, not in the deep dive, but the different perspective of looking at the machine learning, artificial intelligence, and try to find out the intersection point where high performance computing and um artificial intelligence slash machine learning coincide. Then we will see what tools we have in our hands and what can be utilized to make the most out of whatever we have, the hardware resources or the software resources. And then we'll take a look at the specific libraries which we have, which is MRAPage2 and the tools from Exascale Solutions. So let me start my presentation with this one. So most of the times, if we look at the problems which are there for artificial intelligence or machine learning, what do we do? Either we are calculating the probabilities to choose the most probable next event. We could be performing very huge searches, deep searches, or dense searches into the large graphs or large data set. We can be solving Markov models and perform decision making, even solving lotteries, you know. So when we are calculating some of the outcomes, then sometimes we need to solve the lotteries also. Um, Similarly, in machine learning, what basically what we do when we look at the perceptron, the very basic idea of the machine learning is perceptron. So when we take a look at it, what do we do? Multiply the weight matrix, add it to the bias, and get the results. So multiply and add, which is called the reduction operation. Similarly, there are matrix multiplications. So for example, when you're doing a pixel correspondence where you're solving the pixel correspondence problem, then you have an image of 1024 cross 1024, two images basically, and then you're solving a minimization problem. So that is something very extensive. And similarly, when we are running softmax, for example, then we are calculating the exponentials, we are finding out the square roots, when we are finding the Euclidean distance, we are doing divisions, when we are normalizing the stuff. So so all of the times what we're doing is mathematical operations which are CPU heavy. So what does it all needs? We need CPUs, we need GPUs, we need vector processors, we need distributed computing. And even the future is quantum computers. So that is where the hardware technology is moving these days. IBM has demonstrated very good uh, uh, achievement in the area of quantum computers. So this is about machine learning. Now let's take a look at what is there at HPC. So when we talk about HPC, it is high performance computing, obviously. So which is used to run the complex scientific jobs on parallel computers to save times. Because the serial computers are too slow to solve n-dimensional or to perform the complex mathematical equation solutions when you are solving the partial differential equations, when you are solving the matrix multiplications. The serial computers are inherently slow. So the idea of high performance computing is basically divide and conquer. Uh, what do we do there? We have a data set, we distribute it among the compute nodes, run the same program, and then once all the threads or all the processes finish their job, they submit back the results to the host processor. Um, and the host process basically clubs the results and obtains the final answer. So this is what most of the times we are doing in the high performance computing. But how it is enabled? With the help of efficient networks. When I'm saying networks, it is the um, uh, communication networks. For example, RDMA capable networks, InfiniBand, then OmniPath. Those are some high performance, highly efficient network interconnects. And why do we need it? Because when we are running HPC job, you need to distribute the data across the cluster or across the set of nodes. So the faster you move the data from one node to the other node, the faster your program runs. What else we need? We need efficient compute hardware. So these days you might be seeing that AMD is coming up with new processors, which has more than 100 cores. There are new processor from Intel, which has new cores, and they have more efficient and more efficient cache designs, more and more efficient memory bandwidth optimizations, or NUMA architecture is there these days, which is playing a very big role in achieving best performance out of the given hardware. And what else we need? We need efficient storage and physical memory. So efficient storage in the sense, when you're done processing or processing your data, you need to store your results to the hard disk. Or when you're starting your job, you need to read the data from the hard disk and put it in the physical memory. Now, here the recent developments are NVMe, then iSCSI, then SCSI, then network attached storages. Those are now day by day they are becoming faster and faster. So this is what we do in high performance computing. Now, so so basically in high performance computing, one of the aspect is a message passing interface. So the role of this library is to enable uh, processes which are running on different nodes or different hosts to communicate with each other and pass the messages from one machine to another machine. This was basically founded by a forum of industry in 1992, and it became as a standard. So so this is basically targeted to run the complex scientific jobs which are communication intense or compute intense. And mind it that MPI is not a language or a compiler spec. It is basically a set of APIs. It is just like a C program. So now if we look at what do we have for artificial intelligence or the machine learning is PyTorch, sklearn, NumPy. All these are Python-based APIs. And basically, what do they do is they are OpenMP architectures. OpenMP meaning there will be only single host. On that host, multiple CPUs will be exploited with the help of the physical memory, shared memory, or using GPUs. So if you have 4 GPUs, your PyTorch application will run, and it will try to utilize all the available GPUs to run the job faster and faster. However, the the job which is running on the host never crosses the host boundary. It never goes to the neighboring host sitting next to this machine on the same network. There are some examples of distributed computing and uh, the machine learning application things, which are basically TensorFlow and Horovod. Those are 2 examples I'm naming. There could be more. So what happens here? These are some very good libraries, but they are not specifically tailored for distributed computing. And to configure these is really difficult, basically. Um, so in this case, you need expertise to run your MPI job or run your machine learning job with the help of TensorFlow or Horovod over the MPI. Um, so so can we simplify this intersection of high performance computing and the machine learning? For that, we have certain tools which can be utilized to expedite your job or simplify your administrative job as well as the execution of your programs. So for that, let's take a focus on MVAPITch2 and Axiscale solution tools, what we have at hand, and how we can utilize them. So MVAPITch2 is a very old project. This has been headed by Dr. D.K. Panda, and this is slightly older slide, which is 2021. So now I would say they are celebrating 21 years and continuing. And MVAPITch2 has standard compliance with MPI 3.1 standard, which is the latest. It has support for multiple CPU platforms like x86, OpenPower, ARM, and Xeon Phi. This has been utilized by many of the top supercomputers, which are listed in top 500 list. So some of them are listed here. In 2021, it was 4th rank holder Sunway. However, this is not limited to this one. Now the list has been updated, and it gets updated every 6 months. So it's fast moving target. However, I have put a slightly older slide here. So this library basically provides a lot of optimizations. There are some variants we have. MVAPITch2 GDR is one of them. So I'll talk about that a little later, but let's try to focus on the features which it has. The MVAPITch2, the features it has is they're basically based on MPI 3 standard. They have enhanced performance for all reduce and all gather collective communications. And it supports most of the InfiniBand and Rocky and IVR, whatnot, whatever communication protocols are available, the high performance computing communication protocols. Then it also integrates the NVIDIA GPU. So what will happen is when you are running your job on MVAPITch2 or MVAPITch2 GDR, And if your cluster nodes have a GPU installed, then it will automatically try to find out if the CUDA is installed or not. If CUDA is present, then it will automatically tries to leverage the capabilities of GPU when the MPI job is running on this host or any of the hosts. Um, so it is also equipped with multi-threading and fault tolerance, and supports a wide range of platforms. Of course, the most of the market leaders are integrated with in terms of networking, are integrated with this library, which is Mellanox, Intel, Broadcom, or others. So more details can be found in this link here. So these are some of the performance numbers which we obtain. So if you look at the internode latency, internode meaning within the host. Okay, so sorry, the across the host, it is an intranode is within. So so if we look at the latency curve is really very I mean till 128K there is marginally I mean virtually there is no increase in the latency. However, if we look at the OpenMPI, which is the green triangles, so these are slightly there. You will see a 128K. There is a slight glitch. Similarly, in the performance, in terms of the bandwidth, you will see that smoother curve for the maroon line. Similarly, for the larger message sizes in the intranode, you would find that the latency is kept to the lower side in the this latency curve. So this is all about MVAPH2. Let's try to brief on in a little bit on GDR. So GDR is basically leveraging the GPU, as I told earlier. So in this case, if your cluster has multiple GPUs installed, then MVAPH2 library would try to find out if the GPU is installed and the drivers are present. If those are there, then it will throw the job onto the GPUs instead of utilizing the CPU. So the end effect is your CPU is free for more other jobs which are uh, commonplace in a given host. Um, and the installation of this is really simple. You can just go and download the RPM from the from this link and then install it, and your GDR library is up and running. There are obviously a few prerequisites, but you will have to find out from the documentation, which is open source and available to be downloaded from the MVAPH2 website. So with this, actually, the bottom line is MVAPH2 GDR, MVAPH2 is there, but again, the usability and complex and installation of these libraries are a little bit tedious. So, and clubbing or utilizing all the features which are available with MVAPH2 is a little tedious job, because you have to go through the documentation, find out what parameters can be used when you run your job. So for that, there is a simplification available from the Exascale Solutions, which is again a organization headed by Dr. DK Panda. Actually, it is his own company. Recently, he launched this company under the name of Exascale Solutions, and he is the CEO of this particular organization, and they are giving away the licensed version of HPC tools, and these tools are basically hardened based on the experiences they have learned over the period of 21 years, which they have recently completed. So Exascale HPC is basically to utilize again the MPI CUDA aware MPI capabilities, and the way you can utilize these tools is very simple. You just have to find out ask for a student license from them. You download these packages, run these commands like xscale hpc install, and then things will be readily available for you to use. These are some of the performance numbers which are run on 16 node cluster, and a micro benchmark called OSU all reduce, which is also utilizing the CUDA capabilities. So this was since it is 16 nodes and achieving 12 microsecond is a commendable job. It is not easy to achieve this kind of a latency when you are running all reduce on 16 nodes. So what is at play here is the capabilities of MRAPage2, which is utilizing the CUDA library as well as the optimized software algorithms uh, in the MRAPage2 library to leverage the underlying hardware. So you can see that within 303 microseconds, it is able to, the 16 nodes are able to do communication of 1 MB data. That is basically communication as well as the computation on the data, because this is all reduce operation. So those who are aware of all reduce would certainly appreciate this kind of a number. These are some of the more numbers, more comparisons. I probably would skip to this one. So this is one of the neuroscience application, mini application, which was run using exascale HPC on and compared with HP MPI. So this particular application tends to send a message to its neighboring process over the network and perform some computation. So if there are two modes which can be utilized here, random mode and consecutive mode, to choose the neighbor to whom to send the data. This could be a hello exchange or some other computation problem which rigorously do the communication. So you can see that exascale HPC is giving 36% edge over the HP MPI. Similarly, in the consecutive mode, it is giving us 6.52%. So that way, we can say that exascale HPC tools are really usable and simple to use, give good performance. So students should try these basically to run their jobs if they have access to a cluster or of a medium or a smaller size. Likewise, there is another tool from Exascale Solutions, which is Hpc Ai, and this is especially oriented towards the distributed deep learning kind of job. So if you can see that it under one package, this just by giving a single command, it establishes the entire tool chain. So Conda will be installed, TensorFlow will be installed, MPI will be installed, and Horoword will be installed. Otherwise, what you have to do is you have to worry about the compatibilities and install every package individually. Then it fails and it becomes tedious. So utilizing this Exascale AI tool, the things could be at your tools could be at your fingertips. So these are some performance numbers. If you see, and these are compared against Nickel NCCL, which is the CUDA library from NVIDIA. So if you can see that Nickel, the limit of Nickel is within the host. Beyond 96, it does not go anywhere. However, with Exascale AI, you can reach up to as high as 1500 odd nodes. And if you look at the time per epoch, so when the training was, they were training ResNet 50 using TensorFlow when they ran this application, and they each epoch finished within 3.6 seconds. So total 90 epochs took 332 seconds, which is 5 minutes. So RASNet 50, can anyone imagine training a RASNet 50 within 5 minutes? Certainly not. So yeah, so this is the power this particular tool, these particular tools avail us. Okay, with this I'm reaching to the end. If you have any questions, please feel free to ask, and thank you all.
Any questions, please? Participants? Uh, I think most of the participants have not been introduced to HPC, and I think it would
Okay.
have been a new topic to all of us. And I'm really grateful for you taking time to come here and give us a session on HPC and other things. Like it's actually quantum computing and other things are really a bit higher note on for us because we are on application side and this being on the system side. Thank you very much, Devesh sir, and
Yeah.
we are looking forward to have communication with you in the later days also to come, and with collaboration with SRM also. Thank you so
Okay.
much.
Sure. I'm sure this will ignite few minds,
Sure.
which would try to change their, that's why I've kept it very simple and,
Yes.
um, deep towards the basics. Yep.
Thank you. Thank you so much. And now I request Kavita to give the vote of thanks.
One second, ma'am. 1 minute. Good morning, all. I take this opportunity to thank our chairman and co-chairman for their motivation. I also thank our Dean SNH, Dr. C. Sundar sir, for extending his constant support. I also thank our VPs, both admin and academic, for their valuable support. I take this opportunity to thank our pillar of support, our head Department of Computer Applications, BCA, for his motivation. I thank today's keynote speakers, Dr. Agedas, Assistant Professor, Computer Science, University of Alaska, USA, and Mr. Deve Sharma, Chief Technologist, Oracle, USA, for sparing their valuable time with us. I thank all the participants for joining this session. Thank you all.
Thank you, Kavita. And the participants, uh, Devesh sir.
Ma'am, those who are in the track 3 can remain in the same session, ma'am. The link
Okay.
is same.
Okay. And
Yep.
let us give
Do you,
yes, sir. I think if you would like to join the track also, you can be here. And hello, yeah,
Yes, ma'am, you
yeah,
are
yeah.
audible.
Tell me.
yes, sir. We have two sessions today. Track 3 and track 4 is going to start in a few minutes. Track 3 will be handled by Dr. Swaminathan and Dr. Vijayalakshmi, and track 4 by Dr. Jabas Sheila and Dr. T.S. Suganti. And I request all the participants to join their respective tracks. Track 3 can stay here, whereas track 4 you have a separate track. And the participants, as you know, you'll be announced with the best paper at the end of the session. Have a great day. Devesh sir, you can also join if you are interested. And if you
Yeah,
have,
actually, I have some other engagement. I
sure,
would
sir.
like
Okay.
to drop right now.
Sure,
Thank you,
sure.
Shamla,
Thank,
ma'am.
thank you.
Yeah.
Thank you, sir.
Yeah.
Thank you. Students, you can also watch the track and see how the papers are being presented. That will be of a great help to you.